हुआ है बल्कि I don't know what about the problems with others. Anyway, till now we have discussed Unit 6. In that we have discussed like design of an IR filter with different methods like impulse invariant method, bilinear transformation method. So today I'm going to start with the new chapter, that is Unit 7 we have to discuss. So first we will note down the syllabus and then we will proceed further. And this chapter is a very easy chapter. I can say in DSP this is the most easiest chapter we can say it is as compared to other chapters, and already we have discussed. So this part in signals and system also, some of the part we have discussed in signals and system. Is my screen is visible?
Yes, sir.
Yes, sir.
So you please note down this Unit 7 syllabus, realization of digital linear filter. Is it visible to all? Okay, have you noted?
Yes, sir.
Have you noted the textbooks also? Textbooks, reference books. लिखिए क्या वो सब? Which was the textbook used for DSP? Can anyone tell me? Textbook used for DSP. आता मला पळून जावं लागतं सोडून शिकवायचं तुम्हाला. Am I audible?
Yes,
Am I audible?
Yes, sir.
yes, sir.
Which is the textbook used for DSP?
John G. Prokis, DSP Principle and Algorithm Application.
By John G. Prokis. Okay. और कौन सा है? और कौन सी बुक्स है अपने?
बाबू,
हाँ,
रमेश
रमेश बाबू। ओके, ठीक है. Have you noted in this unit 7 we are going to discuss on realization of digital linear systems, structure for realization of discrete time system, structure for there like two types it is decided, like one is structure for FR filter, direct form, cascade form and lattice structure, and the second one is structure for IR filters, direct form, cascade form and parallel form. So these are the different types of realization we are going to discuss in this particular chapter. And here, as we know that the textbook used for the particular chapter is, again, you can either refer this digital signal processing by John G. Prokis, or as a textbook, I have told you, like, can refer digital signal processing by Ramesh Babu. Okay, so now let us discuss the things here. So direct form 1 and direct form 2 already we have discussed. कुछ याद आता है उसके बारे में? Yes? Anybody? Can anyone speak on that? Direct form 1 or direct form 2? Block diagram representation. सुने क्या नाम है? Have you heard of the name of block diagram, direct form 1, direct
Yes,
form?
sir.
सुने है ना?
Yes, sir.
Yes, sir.
Yes, sir.
Am I audible? हेलो?
Yes, sir.
हाँ हाँ, बीच में कट हुआ था ना, डिस्कनेक्ट हुआ था. Okay. For block diagram representation, what are the main elements? कोई बता सकते हैं मुझे? What are the main elements for block diagram representation? क्या क्या लगते हैं वहां पे?
X of n input, Y of n.
Okay, x of n is the input, y of n is the output. Very good. What else again? और क्या क्या लगते हैं हमें वहां पे?
System block.
हाँ,
System block.
सिस्टम ब्लॉक. ओके, और
Feedback.
फीडबैक. ओके, और क्या लगता है? और कोई बताएंगे? What are all the things to be required?
Multipliers.
Multiplier required. Very good. What else again?
Delay.
Delay is required. और क्या लगता है वहां पे? सिर्फ एक इंपॉर्टेंट पॉइंट बचा है अभी. यू हैव कवर्ड like 2 points.
Operators.
हाँ, और क्या लगता है?
Operators.
Yes, Pratik, you want to say something?
Addition.
Addition is required, adder is required, right? To complete a block diagram representation, we require a delay element, multiplier, adder. तो ये 3 इंपॉर्टेंट चीज है वहां पे. और आपको इनपुट है, like input is required as x of n and output is y of n. And this complete system function we are representing with the help of difference equation. So let us see now. So this is what the diagram. So here this like digital filters are LTI systems and described by the difference equation. वो हमें already पता है. This can be implemented by the help of hardware or software. Okay. So here we are understanding with the two types.
Excuse me, sir.
Yes.
Your
Screen is not
Your name.
visible.
Screen is not visible. हाँ. Okay. Okay. क्या यार obstacles बहुत सारे आ जा रहे हैं. Actually चलो. ठीक है. Is it visible now?
Yes, sir.
Yes, sir.
Right. Okay. What I told is like digital filters are like, as we know that it is an LTI system and which we are represented with the help of difference equation, and it can be implemented in terms of hardware or software again. And also we know that these digital filters are two types. One is FIR and another one is IR, that is finite impulse response and infinite impulse response system. So here to realize this digital filters, we require, these are the main basic components. If you want to just note down these diagrams. So first one is what? Delay element. So what we are giving here, if we are giving the input as x of n and the delay like z inverse we are using, y of n equals to, we are writing it as x of n minus 1. Then we have a multiplier. तो ये symbol use कर रहे हैं यहाँ पे multiplier बोल के. So if input is x of n, then y of n equals to a x of n. And then we are adding one more element as a adder here, like x1 of n and x2 of n. If you add these two terms, we'll get y of n equals to x1 of n plus x2 of n. These are the main 3 elements which we require to realize the block diagram. Are you noting this? Hello? Am I audible?
Yes, sir.
लिख रहे हैं क्या सब लोग?
हाँ, sir.
Note down please. or
Yes, sir.
okay. So then next we'll discuss. So here these are the main elements which we require to analyze this FIR and IR system. Now here as it is like classified into the two parts, like this realization of IR system first we will discuss, and then we will go for FIR system. Okay. So in this realization of IR filter, we have like uh, direct form structure for IR system, direct form 1 structure of IR system, direct form 2 structure of IR system. Then we have a cascade form structure and lattice structure for IR system. तो यहाँ पे अभी so these filters what we have is as we already know the difference in FIR and IR. क्या difference है दोनों में? कोई बताएंगे मुझे अभी difference in FIR and IR? As already we have discussed. और recently आपके friend पंक कौन?
IR is recursive function.
Yes, IR is recursive system and FIR is non-recursive system, right? And then IR consists of feedback and FIR doesn't have a feedback. ठीक है? और क्या होता है वहां पे डिफरेंस? IR is both pole zero transfer function system and FIR is only what? Whether it is pole system or zero system.
Zero system.
FIR is only a zero system again. Okay. So these are the comparison with FIR and IR filter. So then we will write these equations first. Okay. So what we know that this is what a generalized expression for a difference equation of an LTI system. That already we have seen this equation बघितलंय आम्ही. Hello? Whether we have noted this equation like an LTI systems are represented by the following difference equation. Y of n equals to minus k equals to 1 to n, ak of y of n minus k plus k equals to 0, sorry m, bk of x of n minus k. What is ak here? The coefficients of output function and bk are the coefficients of the input function. Here x of n minus k represent the input sequence and y of n minus k represent the output sequence. Are you getting my point? Hello?
Yes, sir.
You just write one line. So parallelly we will write down this the equation. So you just write the title as realization of IR system first. Realization of IR system. Realization of IIR system. In that you write Directt form structures for IIR system. You write Directt form 1 structure of IIR system, Directt form 2 structure of IIR system, cascade form structure for IIR system and parallel form structure for IIR system. शायद lattice नहीं है आप लोगों को. Just write up to this part. Lattice is not there for your syllabus, no? I think again. Okay, in cascade, we have Directt form, cascade form, and parallel form. No problem, right? So we'll discuss on that part. So you just write the up to this part. यहाँ तक लिखो. Start on these 4 parts. Then we will discuss one by one. Or have you finished?
Yes, sir.
Now The next you just write, let discrete time system, let discrete time system let discrete time system characterized by the general linear constant coefficient, characterized by the general linear constant coefficient, difference equation, just note down this, just call it as equation 1. Y of n equals to minus k equals to 1 to n ak y of n minus k plus k equals to 0 to m bk x of n minus k, bk x of n minus k. Call it as equation 1. By taking Z transform on both sides, to above equation, we can write this second equation. So y of n का Z transform क्या आएगा? What is the Z transform of y of n? Z transform of y of n. Hello, am I audible?
Y of Z.
Y of z is equals to minus 1, that summation I am keeping as it is, k equals to 1 to n ak z transform of y of n minus k written as z transform of y of n minus k.
Z raised to minus K.
Z raised to minus k into y of z, right? Plus, and again I am writing that summation as it is, k equals to 0 to m bk z power minus k x of z. Understood about this equation, second equation? यहाँ पे कोई confusion? Just I am applying a Z transform to equation 1. Then here I am just making the y term one side. So I have taken y of z as a common here. So y of z into 1 plus summation k equals to 1 to n ak z power minus k, y of z in bracket 1 plus summation k equals to 1 to n ak z power minus k is equals to k equals to 0 to m, k equals to 0 to m bk z power minus k x of z. Next line you write, the system function h of z is defined as, we just write this, h of z is equals to y of z divided by x of z, which can be written as summation k equals to 0 to m bk z power minus k divided by 1 plus summation k equals to 1 to n ak z power minus k. Hope you understood this. Let us call it as equation 2. Call it as equation 2. Any difficulty in understanding equation 2?
Sir, it's equation 3.
Huh? Hello? Hello?
Sir, it's equation 3, not 2.
Equation? Hello?
Equation 3. Because
हाँ इक्वेशन
it's
3.
equation 3.
अच्छा इसको इक्वेशन 3 बोल रहे क्या?
हाँ
टू किसको बोले फिर आपने? ये पहला और दूसरा वाला,
ट्रांसफॉर्म, हाँ।
इसको दो बोल रहे क्या? चलो ठीक है, जस्ट 1 मिनट है, एक इमरजेंसी कॉल है थोड़ा, जस्ट टेक द कॉल, जस्ट नोट डाउन फर्दर पार्ट। गुड मॉर्निंग सर, मैं ही कॉल करने वाला था, एक्चुअल लेक्चर चालू था उसका। हाँ वही, वो वैष्णवी जो स्वामी थे ना, उनके फादर एक्सपायर हो गए। आज एग्जाम भी है शायद उनका। हाँ ओके। हाँ 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 ओके। हाँ हाँ हाँ, अच्छा। हम्म। तो क्या कर सकते हैं अभी इसमें? वो लड़की तो बोलती है अभी वो फुल्ली डिप्रेशन में गई है, मैं तो एग्जाम नहीं दे पाते, ऐसा बोल रही है वो। हाँ हाँ, तो करना क्या है उसको? हाँ। हम्म 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 हम्म। हम्म। ठीक है, देखेंगे फिर क्या कर सकते हैं, वही मैं बात करने के लिए सोचा था आपको अभी। अच्छा, वो फोटो कंपलसरी जरूरी है क्या उनका? ओके। हम्म, ठीक है। हम्म, वही वही वही, मैं समझाता हूँ, फिर भी अभी थोड़ा, अभी अभी हुआ है बोल के वो थोड़ा बहुत ये होगा, फिर भी मैं कोशिश करता हूँ अभी उनको कि जाने वाला हूँ अभी उनके पास जाके, थोड़ा मैं उसको समझाता हूँ मैं थोड़ा। हाँ। देखता हूँ क्या कर सकते हैं, ठीक है, मैं करता हूँ कन्वेंशन को जाके, उधर जाके आपको भी लगाता हूँ फोन, थोड़ा आप भी थोड़ा बात करेंगे। हेलो हेलो,
Yes, sir.
Yes, sir.
एम आई ऑडिबल?
Yes, sir. Yes, sir.
सुनाई दे रहा है ना मेरा?
हाँ सर।
ओके। थोड़ा एक प्रॉब्लम हुआ है आज, उसकी वजह से थोड़ा डिस्टरबेंस हो रहा है आज। एक्चुअली मेरे एक रिलेटिव एक्सपायर हो गए और उनके बेटी की एग्जाम है आज, सो आई वाज इन सम कंफ्यूजन विद दैट, लाइक हाउ टू हैंडल दैट सिचुएशन नाउ। ठीक है, नो प्रॉब्लम, विल कंटिन्यू विद दिस पार्ट एंड वी विल फिनिश, देन आई विल हैंडल दैट पार्ट। ठीक है, हैव यू फिनिश दिस पार्ट?
Yes, sir.
Yes, sir.
Yes, sir.
Any confusion here?
No, sir.
Actually, this is all things we have discussed, like h of z equals to a equation to as it is लिखा है मैंने, h1 of z equals to k equals to 0 to m bk z power minus k, and h2 of z equals to 1 divided by 1 plus k equals to 1 to n ak z power minus k. तो यहाँ पे what we are doing is, here this is the first term we are considering, so this we are calling it as like h1 of z, and the second term, this is the second term we are considering, and that I am calling it as a h2 of z. ठीक है, shall I move further part? Shall I move further?
Yes, sir.
Okay. Then next, now we will go with like representing one block diagram. So here the Directt form structure for h1 of z and h2 of z are. So h1 of z के लिए हम क्या लिखे अभी? What is our h1 of z? h1 of z is k equals to 0 to m bk z power minus k. We just wrote down this part. हाँ सर। हाँ हाँ हाँ, वही वही। ठीक है, ठीक ठीक, देखता हूँ सर डाटा। हाँ ठीक, करेंगे सर, कुछ तो करेंगे, क्या कर सकते हैं। हाँ 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 हाँ, ठीक है, देखता हूँ मैं, देखता हूँ कन्विंस करके मैं करता हूँ। ओके ओके, 6 बजे तक टाइम है ना भाई? हाँ ठीक है ठीक है ठीक है। अच्छा अच्छा, हाँ हाँ हाँ, अच्छा अच्छा ठीक है ना, 4 बजे देखता हूँ मैं सिचुएशन कैसा रहता है। 4 बजे अब, हाँ, तो करता हूँ सर मैं पहले। हाँ हाँ, ओके ओके, मैं करता हूँ ना आपके साथ। Okay, so h1 of z equals to like k equals to 0 to m bk z power minus k. Have you noted this? Hello.
Yes, sir.
So I'm just expanding this summation function b0 plus b1 z inverse plus bm z power minus m. So then हमने h1 of z को in terms of y and x we are writing. ठीक है. So I have written it is like y1 of z divided by x1 of z. Then I am writing the equation in terms of input and output function. So y1 of z equals to, तो ये यहां पे अगर लेंगे b0 x1 of z plus b1 z inverse x1 of z plus bm z power minus m x1 of z. If I take a inverse z transform of this equation, y1 of z के लिए what we are writing, y1 of n is equals to b0 x1 of n plus b1. I am applying inverse z transform to this, so we are getting it is x1 of n minus 1 plus dash 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 bm x1 of n minus m. Hope you understood this equation. Any confusion in understanding this? Equation 4. Have you understood? Hello?
Yes, sir.
Am I audible?
Yes, sir.
This equation 4, any difficulty in understanding this?
No, sir. No difficulty.
Okay.
No, sir.
Now, this is what the first structure, as we already know this part, nothing new in that. So this is our input part, x of n, and this is our output part, y of n. So first what we require b0 x1 of n. तो यहाँ पे अगर आपका आउटपुट आया b0 x of n, right? If you want, you can take it as x1 of n लिख सकते हैं यहाँ पे. So b0 x1 of n. Then if I pass this x1 of n through this delay, that is z inverse. तो यहाँ पे क्या आउटपुट आएगा आपका? What will be the term here at this point? कोई बताएंगे मुझे? If I pass this x1 of n through this delay, तो यहां पे क्या आउटपुट आएगा? Anybody? What will be the point at this point, or what will be the output at this point?
X of n minus 1.
So here we will write it is like x1 of n minus 1. ठीक है? It can be written as x1 of n minus 1. Just a minute. तो यहां पे हम, so what I can write here is, तो यहाँ पे I can write it as x1 of n minus 1. So here the part will get it as x1 of n minus 1 यहाँ पे आएगा. ठीक है? So now, तो यहाँ पे क्या आएगा? That is b1 into x1 of n minus 1. The next at this point, यहाँ पे क्या आएगा आंसर? Anybody? क्या आता है यहाँ पे? At this point, what will be the output? Can anyone tell me the answer here? If I pass this x1 of n minus 1 through this delay element, so what will be the output at this point?
x1 of n minus 2.
Yes, it is x1 of n minus 2 यहाँ पे आएगा. ठीक है. So likewise, if I pass on this x1 of n through this delay element, तो यहाँ पे लास्ट में हमें क्या आएगा कि x1 of n minus m आएगा. Right? So finally, if I add all these things, so then I will get the output will be equals to this equation. So this is the way how we are representing with, and we are calling this as like system 1. we हम बोल सकते हैं इसको. We are calling this as system 1. Okay. Or so this system 1 simply I will call it as like h1 of z. I can call it is. बोल सकते हैं? Yes.
Yes.
So then similarly we have
Yes, sir.
to analyze for h2 of z. तो h2 of z को कैसे analyze करेंगे अभी? Hope you have noted this diagram also. Diagram लिखे है ना?
Yes,
Yes,
sir.
sir.
Then next we will realize for h2 of z. h2 of z is the all pole system and is given by h2 of z equals to 1 divided by the only denominator part we are writing 1 plus k equals to 1 to n ak z power minus k. h2 of z equals to 1 divided by 1 plus k equals to 1 to n ak z power minus k. Okay. Then same procedure will follow for this also. And with the same procedure, we will get this as the final answer. Just note down, you can understand this. Nothing is the difficulty part. So already we have discussed. So anybody having any confusion here or any problem, let me know if you are not understanding at any point. कळतं ना इक्वेशन्स कसं यायला लागलं तिथं? हॅलो.
Yes. Yes.
हाँ सर.
Yes, sir.
काही डिफिकल्टी नाही असं मला वाटतंय. Like all are simple and already we have discussed these things many times. Finished?
Yes, sir.
Hope you have taken block diagram also. तो क्या डिफरेंस है अभी ये डायग्राम में और पुराने डायग्राम में, कोई बताएंगे मुझे? So system 1 is we are starting from input side और ये आपका output side है, ठीक है? So here like if you like y2 of n, if you pass through this z inverse, so what we will get at the answer at this point? तो यहाँ पे output क्या आएगा आपका? So what will be the output at this point?
y2 of n minus 1.
So here we will get y2 of n minus 1. Okay. And then next, if I pass this y2 of n minus 1 through this delay, what we will get again? y2 of
n
क्या आएगा?
minus
n minus 2. So likewise, if you go on passing this y2 of n through this delay elements, so we'll get the output finally. क्या मिलेगा यहाँ पे लास्ट को? So y2 of n minus n रहेगा यहाँ पे. Okay. So finally इसको सबको ऐड कर रहे हैं हम. So that will be the block diagram representation for this second part, like the delay element again. So second transfer function. Now further if I move again, so ये structure ऐसा दिखता है, right? So here what I am doing is I'm just cascading the two elements. We are cascading h1 of z and h2 of z. So this wise this structure is going to be generated. Hope you are understanding this. This is like h1 of z and h2 of z, and then we are combining the two diagrams. Okay. This is what we are calling it as direct form 1 realization of IR system. Direct form realization of IIR system. Direct form 1 realization of IR system we can call it is. So here, I think if you are looking at direct form 1 realization of IR system diagram, that block, first block is for h1 of z, which equals to, we have it is y1 of z divided by x1 of z. h2 of z equals to y2 of z divided by x2 of z. Are you getting this part? Any difficulty in understanding this? काय अडचण इथं?
No, sir.
This is our system 1. ये पहला part जो है अपना system 1 है. So this is what we are calling it as system 1, first part. So nothing new I am telling here. Already we have discussed these things repeatedly. Have you noted this? So parallelly I will take the attendance till you take the diagram. Roll number 1. One is that. Roll number 1. आता जरा खरा क्लास मध्ये कोण कोणा कळतंय आपल्याला. 2. Roll number 2. 3. 4.
Present, sir.
1, 2, 3 absent. 5.
Present, sir.
6.
Yes, sir.
7.
Yes, sir.
8.
Yes, sir.
9.
Yes, sir.
10.
Yes, sir.
Continue the present numbers.
11. 12.
13, 14. Okay.
13.
Okay. 14 is there. 15, 16, 17.
17. Present,
Continue.
sir.
Continue the present numbers.
18,
Okay. Next.
19,
Next.
20, 21,
22.
Next.
23.
Next.
24.
Next. 25, 26, 27,
27.
28,
29.
30.
31. Do it fast.
32.
31. Ah,
33,
34. 35. 36.
37, 38.
37.
Okay, 38, 39.
39.
Okay,
39.
okay, 40.
41.
Ah, next.
42.
43, 44.
44,
Continue.
45, 46,
Ah,
47,
next. 48, 49, 51.
51,
Ah, next. 52, 53, 54, 55.
56, 54,
Continue.
57,
58. 58 is there. 59, 60, 61, 62, 63, 63.
64,
Next.
65,
66.
66. Yes, sir.
Okay. 67, 68.
present, sir.
Continue. 69, 70.
Present, sir.
Call the present numbers. 71,
71.
72, 73,
yes, sir.
74.
Yes, sir.
Okay. So thank you. We'll close the session here and I will continue again further. Anybody has missed out?
Sir, roll number 1.
कुठं गेलतो मॅडम?
सर होते पण माझा नंबर त्यावेळेस आवाज कट झाला नंतर नाही बस.
हा ठीक आहे. चला. आणि कोण आहे?
72.
72.
70.
Okay. Okay, you are present. Who else is there again?
16, sir.
कुठं गेलतो मॅडम?
सर इथंच होते.
मग आवाज अटेंडन्स दिला नाही. मी अटेंडन्सचा पॅटर्न कधी कधी थोडा चेंज करत असतो. ठीक आहे. चलो.
Sorry, sir.
और कौन है? रोल नंबर 2,
54.
3, 54. प्रसन्ना. ठीक है. और 37. Who is 37? Gayatri Kuntala. Okay, no problem. We'll close the session here and we'll continue again further.
7.
37 present, madam. You are present.